Alright, back with some more of the video solutions for these problems that are helping you revise term 1. These ones are about the distance formula. Find the distance between each pair of points. So remember, the distance formula is just Pythagoras' theorem. Usually we would start with the distance. And after getting it already, it didn't want to write. There we go. Distance squared equals the difference between your x coordinates squared and your difference between your y coordinates squared. But you probably remember the rule more like this. I just like to remember where it comes from so that if I'm stuck in an exam, if I'm starting to worry a little bit, I can just think, oh, that's right, I remember where it comes from. And you can just think your way through it and you'll be fine. But there we go, difference between the x coordinate squared, difference between the y coordinate squared, and obviously that then gives you the hypotenuse squared. We don't want the square of the distance, we just want the distance, so that's why we square root. So filling in the blanks for this one, d is going to be the square root of the difference between the x coordinate squared. We've got 4 minus 1, which of course is going to be 3 squared, plus 5 minus 6 squared. So the distance is going to be the square root of 3 squared is 9 plus 1. It's going to be root 10. And I've got a big long vinculum there, but that's okay. So the distance between those two is root 10. Over here in question 15, same idea, except we just count 1, 2, 3, 4 down. Just check your scale and make sure that it is actually going up one at a time. It is, so we're all good there, but that's sometimes where they like to try and catch you out. And your horizontal difference between the points is 3 across, and again our scale is fine. So therefore, look, this one is 3, this one is 4. I don't think it takes a genius to remember your 3, 4, 5 Pythagorean triad. So you could go through the same formula that we had before, or you can just do it like that, and that works fine. Rightio, a bit of simplifying. Some of us still struggling with these fractions. You need to make sure you're on top of these. This is going to be really important moving forward, so let's just make sure we get them right. Here we go. Remember, you can only cancel common factors, so anything that's a factor on the top and a factor on the bottom we can cancel. So straight away I can see 7 goes into 7 once and it goes into 14 twice. I'm now looking at 2 and 4. They're both even numbers, so of course 2 goes into 2 once and into 4 twice. Now in terms of the numbers, I've got 1, 2 on the bottom and a 13 on top. They're not going to simplify, are they? On the bottom I've got 2 a's being multiplied together. This one can cancel with one of those, but also this a cancels with another one, so I'm just left with a to the power of 1. So all together I've got 13a divided by 1 times 2 is 2. And that's all there is to it. Shouldn't be too complicated. Hopefully you were going well with these. Here we go, division when dividing by anything, but you will probably remember it as when you're dividing by a fraction, you multiply by the reciprocal. But the same is true when you're dividing by 6. You multiply by 1/6, that will give you the same thing. So that rule is always true. So there I'm going to take the time to show that step first. Now this is why I was changing the colour, just to make it clear what I'm doing when I'm cancelling common factors. There's a 4 on the top and the bottom. They each cancel. All my x's are on the bottom. There are no more x's on the top, so there's nothing I can cancel there. 11 and 15 do not share a common factor. So that's it for my simplifying. Now I just multiply across. 15 by 1 is 15. And on the bottom I have 11 times x to the power of 5 times another x. That's 11 x to the power of 6. And we're all done. Let's move on. Oh, look, division again. So I'm going to have to multiply by the reciprocal. But before we even do that, you can see in this first bracket v plus 4 and v plus 4 is a common factor. So that's the same as 1 over 1. Nothing to cancel there yet, so let's wait until our next line before we get carried away. So this term on the left is now just v minus 14. Some of you will like to keep it over 1. There's certainly no need to, but I know some of us still only been at school for 14, 15, well, been alive for 14 or 15 years, been at school for at least 10 of those. So hopefully we remember that v minus 14 is the same as v minus 14 over 1. Either way, let's multiply by the reciprocal. V plus 13, v minus 17, and this is divided by 7 times v minus 14. And now you can see the common factor. These are all factors. That is one term in bracket. A vinculum acts as a set of brackets, so that's okay. I can cancel that v minus 14 term with this v minus 14 term. There's nothing else there to cancel. My screen wanted to scroll there. Hope didn't make you... Oh, it's doing it again. For some reason the touch sensitivity isn't recognising when I'm using the pen on my hand. But that's okay, just bear with me. So 1 times 1, we're just left with what's on the right there. V plus 13. V minus 17. Over 7. Now, that's actually pretty nice. Did the instructions say to expand and simplify? It just said simplify. Generally, we love... oh my goodness, it's doing it again. And it won't go back the other way. That's crazy. Generally, we love factorized expressions because then when we're solving equations, we can set that equal to 0 and solve it. I'm not sure how the answers have this one written, but let's just... Once I find where my cursor is again, there's no little circle, so it's really hard to find it, but I've got it there. We could expand this bracket. V by V, V squared, these brackets. 13 times V would be 13V, V times negative 17, so I've got positive 13 minus 17, that's negative 4V, and then we've got 13 17s, which I think are 221. I'm sure you can check that for me, and divide by 7. How did I get the 221? Well, I just did 15 squared was 225, and then that's 2 either side. So it's just an application of your difference of 2 squares rule, your favourite rule in maths. But you can use your calculator for that. You can just do it on the side of your page. Any of those are fine. You can go 10 times 17 is 170, and 3 17s are 51 and add them together. All good whichever way you want to do it. Simplify writing each answer in scientific notation. All right, well, I don't have a calculator on this computer at the moment. My emulator seems to have disappeared. So the interesting thing here is this one's being multiplied by 10 to the negative 2 and this one's being multiplied by 10 to the 2. When I multiply them together, that's just 10 to the 0 or 1. So they can be simplified a little bit. So then I've just got 6 times 6.04, which of course will be 36 point... was it 24? Yeah, I think it is. And of course we've got to write this in scientific notation. So this is 3.624 multiplied by 10. And you can put the 1 there if you want, or you can leave it. Either one is fine. Oh, 9.3 divided by 1.7. I don't want to waste your time watching me do long division. Let's go over to Desmos. There we go. Oh, 36.24. Is that what over there? Oh, I believe it was. Yeah, so that's good. My goodness, I've just got to remember to go to the question. 9.3 by 10 to the 1 divided by 1.7 by 10 to the 0. So here we go, bracket 9.3 times, 99.3, 9.3 times 10 to the power of 1. Obviously I don't need that, but let's just put it anyway. On your calculator, remember the EXP button would do the times 10 to the power of, and then you just need to type in the 1. We're dividing by 1.7 times 10. Oh, the times didn't work. 1.7 times 10 to the 0. Well, I'm not going to type that in. 10 to the 0 is 1. You know that. So just divide that by 1.7. I've got 54.7. And so that's going to be 5.47 times 10 to the power of 1. Oh, except did I have negative 1 up there? I had positive 1. Helps to read the question. So that's 0.547. Okay, so just making sure I got that right. So 0.547. It's often good to do it that way first and then write your answer in scientific notation or standard form afterwards. So 5.47 by 10 to the negative 1. Hopefully you're right to do that on your computer, on your calculators or computer or whatever you're using to help you with your calculations. This one here, solve each equation for A. Oh, well, this is back to kindergarten maths. So here it's got a Z in it, but we can still solve it for A. Z's just a variable I don't know. So I'm just going to perform inverse operations. I add 3 to each side. So this is going to be Z plus 3 equals 4A. And of course, once I've got that far, I'm just going to divide by 4 because that's the opposite of multiplying by 4, the inverse operation. So I end up with Z plus 3 divided by 4 equals A. And we're all done. Over on the right-hand side here, I want to solve for X. Well, this is a negative X. What I might do, you don't have to show this working, but sometimes it helps you to stay organized. I'm going to add X to each side, so I get my X on its own rather than shifting the K and the Y, and then I'll just subtract U from the left-hand side. So I better do the same from the right-hand side so it maintains equality. Now I've just got x on the left hand side, and I have k plus y minus u. And that's all there is to it. Question 22. 0 equals x plus 5x. You can probably already see it, but on the right hand side I have 6x's. So 0 equals 6x. Dividing by 6, well, 0 divided by 6 is still 0. So x equals 0. And that's pretty messy x, but hopefully you can make sense of what I did there. On the right hand side here, could try and divide by 8. That's going to introduce ugly fractions, isn't it? So this is a situation where you want to use your distributive law and expand that bracket on the left first. So 8 times r is 8r. 8 times 7 is 56 equals 38 plus 5r. Now, of course, you want to get all your r's together. I've got fewer of them on the right than I do on the left, so I'm going to get rid of those. I'm going to subtract 5r from each side. That just means I'm going to end up with a positive number of r. We're almost always better working with positives than negatives, so that would make sense. Unfortunately, that means I've got to get rid of this 56, so I'm going to subtract 56 from each side as well. So I'm going to subtract 56. What does that give me for my next line? That previous line is equivalent to 3r equals, and 38 minus 56, I believe, is 18. Dividing by 3, we're going to get r equals 6. Of course, you can always check these, can't you? If I put a 6 in there, 13, 8 13s, 80 and 24, 104. 38 plus 30. Well, that doesn't look right at all, does it? What did I do wrong? Look, negative 18. Lucky I checked it. 38 minus 56 is negative 18. R should be negative 6. Let's see if that makes more sense. Negative 6 plus 7 is 1. 8 times 1 is 8. 38 plus 5 times negative 6. 38 minus 30 is 8. There you go, got it right. Always worth doing that step, isn't it? Easy to leave out a negative somewhere along the line. Take the time to check that. You'll still have plenty of time in the exam if you've practiced and you're used to working quickly. Over here, I must admit I would probably divide, because I can see 4 and 12 share a common factor of 4, but I think talking to a few people in my class who've tried this one, they preferred expanding, so I'll do that. That's probably the preferred method across year 10, so we'll go with that. That's okay. So negative 4 by 1 is negative 4, negative 4 by 7b is negative 28b, and that's equal to 12 by negative 2b is negative 24b, and 12 by negative 2 is negative 24. We're going to collect all of our b's together. Negative 28 is less than negative 24, so I'm going to add 28. Always get rid of whichever one's the smaller one. That way we'll end up with a nice positive number. That means if my b's are going to be collected on the right, I want to get rid of this 24. Opposite of subtracting 24 is to add 24, so I will do that to both sides of the equation. What does that left me with? Negative 4 plus 24 is 20. 20 equals negative 24 plus 28. 20 equals 4b. Therefore, 5 is equal to b, or b is equal to 5. You can substitute in that and check. 35 plus 1 is 36 by negative 4, negative 120 minus 24, negative 144, something like that. Negative 10, negative 12 by 12, negative 144. Looks good to me. Over on the right here, 2b minus a half equals b plus 2/3. Well, even though there's fractions and my instinct is to get rid of them, and that's not a bad instinct, I can see here that the b's are actually both okay. They haven't been bothered by those fractions, so I'm just going to get my b's together. I've got 1 on this side, 2 on the left, so I'm going to subtract b from each side. Well, that's pretty nice, because I can see I'm only going to have b left. That means this half I've got to get rid of, so I'm going to add 1/2 to each side. What does that simplify to? Well, on the left-hand side, I just have b, and on the right-hand side, I've got 2/3 plus another half. How do we do that again? Change them into sixths. 2/3 is 4/6. 1/2 is 3/6. Bet you that sounds good on the microphone. And altogether we have b equals 7/6. You could write it as 1 1/6, but we're more than happy with improper fractions now that you're in year 10. All right, next one. Interestingly, these catch people out sometimes. It's just the same thing. We do the same procedure. We get all our b's together, and then we worry about everything else. On each side, we're going to simplify first. Before we try and shift everything across, I can see I've got like terms on each side that I can add together. So let's do that. Here I've got negative 2.7b. If I add 0.3b, negative 2.7 plus 0.3 is negative 2.4b. 1 plus another 1.34 is 2.34. And on the left hand side I've got 0.2b minus 1.3b. That's negative 1.1b. Okay. You remember by now that we want to get rid of the smaller amount. Negative, oh, there I go again. I've been doing well not to do that. Negative 2.4b is what I want to get rid of. So I'm going to add 2.4b to each side. Oh, that's where I lose my cursor. Found it again. So now I have 2.34 is equal to a negative 1.1. That's going to be 1.3b. And so we divide by the 1.3. 2.34 divided by 1.3 is equal to b. I think I might let Desmos have a bit of fun and work this one out for me. 2.3 divided by 1.4. I don't even think that was halfway close. 2.34 divided by 1.3. I knew that wasn't right. 2.34 divided by 1.3. And we got 1.8. Oh, I should have known that one. So therefore, b equals 1.8. We might do these last two, get up to 29, and then I might take a break and start another video. We're 15, 16 minutes in now. It's probably long enough. This next one's pretty fast though, isn't it? I'm going to add 74 to each side. I don't even need to show it here to get r on its own. 74 and 24 is 98. There you go. That one saved you a bit of time. Lucky last over here, also pretty quick. I've got negative x on the left. You could keep that there and get rid of the 89 and then multiply by negative 1. Instead, I'm going to add x to each side. That'll make it positive when it turns up on the right. And of course, to get rid of the negative 133, I need to add it. So I add 133 to each side. And that's going to give me something equals x. I reckon it's going to be 44 equals x. And we're done. Oh my goodness, I'm getting all sorts of things popping up. All right, catch you in the next video. I hope you're going well with these and you're enjoying remembering all your work from last term. See you next time, guys. Cheers.